Hello and welcome to another online teaching. My name is Ing.Momoh Kenie. Just in case you have any comment to any of the videos, you can do that via WhatsApp on 076-627-336. Have in mind that you can access these things again on YouTube by searching Momoh Kenie. Those of you who are on WeChat can also get access to the class at 6 p.m. on WeChat. Today we are going to continue with elasticity where we stopped in the physics. We are going to look at past questions now, relevant past questions. The first question you can see on the board was a question that came in private was 2020. It was a private class question last year, and it reads, a steel wire 1.0 meters long, that is the original length. The original length is 1.0 meters. We have the original length, which is the unit of that, or the symbol is L0, according to them is 1.0 meters. After that is suspended vertically from a support, and a load are hung at its free end. If the strain in the wire is 3.5, the strain in the wire now, according to them, they are saying the strain is 3.5 times 10 to the power minus 4. No units. Calculate the energy. Energy, we don't know. But we know very well that the expression for the strain, the formula for the strain we established here, the strain equals the extension divided by the original length. That was the formula for the strain of the material. Now the strain of the material is given. The strain according to the question is 3.5 times 10 to the power minus 4 equals the extension we don't know. The original length of this one is 1.0. So when we cross multiply here, we now find out that extension equals 1 multiplied by 3.5 is the same as 3.5 times 10 to the power minus 4. Extension is in meters. That is the extension of that particular material. If it is the extension, we can now go ahead to get the energy stored. If you recall again, we said the energy stored in an elastic material is given by the expression of half Fe or half Ke square. We have half Fe or half Ke square. You can get E equals half Fe or E equals half Ke square. We did not use Fe here because there is no force in the question. We are using K because according to the question they say force constant. Force constant K equals 5.0 times 10 to the power 5. You can get K here. The extension we have just calculated it here as 3.5 times 10 to the power minus 4. So the required formula for the energy will be this one. Hence, if that is the case, we have half times K is 5.0 times 10 to the power 5 times the extension is 3.5 times 10 to the power minus 4. We have 3.5 times 10 to the power minus 4. But everything is squared. It's a square term, so you square that. This one becomes 2 can go into 5. When 2 goes into 5 is 2.5 times 10 to the power 5 here times we now have 3.5 square. 3.5 square will give us a value of 12.25 times 10 to the power. We have minus 4 here, but minus 4 is raised to power 2 also. So when you have two powers, you multiply them. The power here is minus 4, and then the other power is 2. Minus 4 times 2 becomes minus 8. So if that is the case, the energy stored becomes, I will now multiply the numbers 2.5 and 12.25 times 2.5. That will give us 30.63. 30.63. According to law of indices, 10 and 10 will just take 1 and add the powers. Minus 8 plus 5 becomes minus 3. SI unit for energy is in joule. The other question was a question in private was again 2018. It came in private was 2018 and it reads, a 1.8 meters long piano wire. There was a wire. The wire was 1.8 meters long. That is the original length. You have the right to say the original length, which is L subscript 0, according to them is 1.8 meters. That is the length of the wire. Has a diameter of 0.2 meters. You say the diameter D, according to them is 0.2 meters. Calculate the tension in the wire. If it stretches 0.3 centimeter, that is the extension. It stretches. That means what ends or adds to that? The extension E, according to them, is 0.3 centimeters. But the standard unit is meters. So for you to convert from centimeters to meter, you divide by 100. If you divide 0.3 by 100, you get 0.003 meters. That is the extension. When tightening, Young's modulus is this. We already know very well before we progress that the moment the diameter is given to us, you can get the area. And the formula for the area, we said, is pi d squared divided by 4. In the analysis will be last. Now pi is 22 divided by 7, which is 3.14. Times the diameter is 0.2. You say 0.2. But because of the square, you square that. Everything has to be divided by 4. So the area will give us 0.2 square times 3.14. Everything divided by 4 will give us 0.0314 meter square. We have got the area. Now if it is the area, the Young's modulus is given to us. But if you can recall last, we said Young's modulus is given by the stress of the material divided by the strain of the material. And we said the stress is force over the area divided by the strain, we said is extension over the original length. So the Young's modulus becomes F over A times L0 will go up and E comes down. So if that is the case, I will now bring that expression here and it becomes Young's modulus equals F times the original length, everything divided by the area times the extension. Now the Young's modulus, according to the question, is here. The Young's modulus is Young's modulus equals 2 times 10 to the power 11. So this is 2 times 10 to the power 11 equals the force is the same as the tension. Have in mind force is the same as tension. So if that is the case, the force here times the original length. The original length is 1.8. We have 1.8 there. Divide that by the area times the extension. The area is 0.0314 times the extension E. The extension, according to the conversion we did, we got 0.003. 0.003. That is given us 2 times 10 to the power 11 equals F times 1.8 is 1.8 F. Now when I multiply these two figures here, I will get 9.42 times 10 to the power minus 5. We now cross multiply them. Whatever we have here, we multiply by this. And this multiply by that. So if we cross multiply the figures down there, we will now have an expression that is 2 times 10 to the power 11 times this other figure, 9.42 times 10 to the power minus 5. That is going to give us 1.8 F. For us to get F, you divide both sides by 1.8. You divide here by 1.8, you divide here by 1.8. So the formula or the expression for the tension is, you are now going to multiply this 2 times 9.42 divided by 1.8. Then you go to the powers. I have 9.42 times 2. The answer divided by 1.8. That will give me 10.47 times 10 to the power. Law of indices, when the bases are the same, you just take one of the tens, one of the bases, and add the powers. Minus 5 plus 11 becomes 6 newtons.